Okay, so we're going to go over determining the actual values of a max and a min in a formula. We have our three forms for quadratics. Okay. Very first equation. What form does it relate to?
Vertex.
Yeah, that's right. This relates to vertex. So what I'll do is I'll just kind of highlight them certain colors. We'll go with yellow for vertex. Actually, let's undo that. Highlight this part. Vertex. So we know number one is vertex. What about number two?
Standard.
Why would you say standard?
Because it has the 2x there.
Mm-hmm.
And then in brackets it has the x plus 2.
X plus 2, yeah.
The family rooms at school, I have to go back and get them. I left them on a desk.
Okay. Well, let's look at the powers here. Are there any of these to the power of 2?
No.
No. So neither of these are the power of 2. First thing you always notice, especially if you have a quadratic, to be in standard form, we need to have a variable that is by itself to the power of 2. Okay? So what version, let's talk about one that has brackets, and are there any powers around these brackets?
No.
No. Are there any versions that have brackets with no powers around them?
Yeah.
Which one?
Factor.
That's right. So this is similar to factor form, though a little different looking, because think of factor form as having like 3 terms. Well, this is our A term. That's the coefficient in front. And we definitely have a bracket at the end here. The only difference is this one is technically just the x. The only difference here is they didn't write in the value. They could have written x subtract 0, okay, and then had that in there. But because x subtract 0 is just x, this little x here represents this bracket. So it's just a little harder to notice, okay? Here would be the other bracket, and the 2 would be the A. So this is actually a factored form, okay? So we'll say factored in green, okay? What about 3?
Standard form.
Why would you say standard?
Because there's a power outside the bracket.
Outside the bracket. Is there any brackets in standard form?
No.
No.
Oh, never mind. It's vertex form.
Okay. Now, technically, this one can kind of fall under both. This one can be, you're probably right, it looks closest to vertex form, but this is also sometimes known as a factored form. Okay, this one's a bit tricky. So we can actually deal with it either way, and we're going to discover how to deal with both of them. So this one's kind of a trick. It can kind of be both, because if I were to split this, this would be x plus 2, x plus 2. Well, when it looks like that, that definitely looks like factored form. Okay? But in the style it's in right now, you're probably right. It looks closest to vertex form. So that would be a vertex form. And then finally, the last one. What does the last one kind of look like?
Standard form.
Why do you say standard form?
Because 6 is basically the A with the X, and then there's the power there.
Okay, so what term are we missing? Are we missing the B at X or the C?
You're missing the B and X.
That's right. The middle term is just not there, that's all. But it's still in standard, what's considered standard form. Okay, so we'll highlight that one too. So standard form here in pink. That's what number 4 is. Good. So we have all of our different forms. Now we actually have to determine a maximum value. Remember we talked about vertex form being the absolute easiest way to do it. Okay? When something's in vertex form, it's very easy to find the value of the max and min because that's the vertex. Okay? And you can find the vertex from just looking at vertex form. So I'm going to copy and bring this down here. And let's zoom in. Okay? So let's just focus on vertex form to start. Oops, a little much. Okay, so our vertex form. If you recall, I said that the h value is actually the x value, and the k value is actually the y value. Okay, the only difference is it's kind of the opposite of what the h is, and the y value is exactly what the k is. Okay, so we're going to scroll up a little. If you look, in this vertex form, remember yellow is vertex. In this vertex form, which is the h? Which number is h?
3.
3. Now, is it a positive or negative?
A positive.
Okay. So when we put it into vertex form, what's it going to be? Positive or negative?
Negative.
Negative. That's right. We're going to flip it. Okay. So the vertex form of this, of number 1, don't want green. Let's use black. The vertex form of that is
3b.
3 would be the x. And what will our y be?
2.
Well, I2. Is there any value in front of it or operation?
Negative.
Yeah. So we actually take the operation in front always. Always consider that. Remember, the k is exactly what it is. So this is the value of what?
Negative 2.
Negative 2. So our our y value is negative 2. So that's exactly what the vertex is. Okay, that's the exact coordinate. So wherever it is. Does it open up or down?
It opened up.
Up, okay. We know that because it's positive. So we know we have a parabola opening upwards. This is for number 1, okay. Vertex at the point 3 and negative 2. Is it a max or a min?
Pointing down, it's... Wait, going up, it's a minimum.
That's
going
right.
Down, okay.
So this is a min. That's it. You got that, okay? I'm going to jump to number 3 just because it's in vertex form too. It's just a little harder to see because I just want to stay on that pattern here, okay? First of all, I want to point out 2 things. First of all, the a value of this is technically, what number can we say is right in front of this bracket?
1.
Yeah, they usually talk about imaginary ones. Now, and if I were to say we were to add an imaginary number, I want to know a number that I could add that wouldn't affect this. So if I were to add something to the end, what number wouldn't affect this?
0.
0, that's right. And that's exactly what that is. So this 0 represents which letter?
K.
K. Okay. The 1 represents?
A.
And what does that 2 represent?
H.
That's right. Good. So now that we've figured this all out, what is the value of my vertex?
Negative 2 and 0.
Good. Negative 2 and 0. That's my vertex. Is it open up or down?
It opens down.
Why down?
Because wait, no, it opens up.
That's right. Why?
Because the 1 is positive
That's
and
right.
not negative.
Good. So it's positive, it opens up. Okay. The vertex is negative 2 and 0. That's that exact coordinate. Is that a max or a min?
It's a minimum.
Good. So we got that. So using vertex form, you can see it's easy to find those values. Now the other 2 are a little more tricky. In our factored form here, okay, we have our factored form here. I am going to go down a little. That's 2x and x plus 2. I'm going to show you how to do this, okay? So question 2, they gave us the number 2x and x plus 2 is equal to f at x. Okay. Now this is in factored form. Well, factored form helps us find the x-intercept the fastest. I told you about that, right?
Wait, which one is that one?
This is our factored form. Okay, this was question 2. You just can't see it all on one page. That was this one here. Okay, this 2, that was our factored form. Okay, so we scroll down a little here. Factored helps us find the x-intercepts fastest. Why? Because we've split our x's, and what we're going to do is an x-intercept is when we cross the x-axis. Well, what is my y value when I'm crossing the x-axis? Y is equal to what at this point?
0.
0. Because we know f at x essentially is our y value, I'm going to change this equation. I'm going to say 0 is equal to 2x times x plus 2. Now what we have here is a multiplication question. Okay, we're multiplying 2x by x plus 2, whatever term that is, so it's multiplied by. Okay, well, in order to get a 0 when multiplying, what do one of the values have to be?
0.
0. We can't multiply any other 2 numbers and get 0 unless one of them is a 0, right? Any other number would give us a real value. You have to be multiplying by 0 to get a 0. So, with that being said, that means one of these terms, either this one or this one, needs to be 0. Okay? So what I'm going to do is, I'm going to go on the assumption that maybe in one case, 1 is 0, and in the other one's 0. So I'm going to split the equation. I'm going to split this part and set them both equal to 0 separately. So when I do that, I'm going to get 0 equals 2x and 0 equals x plus 2.
Yeah.
And then I'm going to solve for x. In this one, how do I move the 2 over? How would I get x by itself?
2 and have a bracket with x.
Well, if this is 2x, right, this value of 2, how do I get it to the other side? Or how do I get x isolated?
It has to be negative.
Well, because it's multiplied, we use the opposite operation of multiplication.
And divide it.
Yeah, that's right. So we got to divide both sides by 2. So these 2's cancel out. And 0 divided by 2, do you know what that is?
0.
That's right. So one of the values, one of our x-intercepts is at 0. Okay. The other one, how do I get x by itself? How do I move that?
You're gonna subtract it.
Yeah. So it'll be 0 subtract 2 equals x. What does x equal?
Negative 2.
That's right. So we have one at 0 and another point at negative 2. Now, which direction did this open? Looking at that first term.
It opened up.
Up. Okay, so we know we have some parabola that goes like this. It definitely opens upward. We got our 2 x-intercepts. Now, these 2 x-intercepts are going to help us because we know a vertex of a parabola is going to go right through the middle. I'll try to make that as best as I can in the middle. Okay, that's where the vertex is going to be. So we know it's going to be which value, max or min?
It's going to be a minimum.
That's right, because it opens upward. It's going to be a min, but we actually have to find what the value is. Well, in order to find the value, this is called the axis of symmetry. So we have to find the axis of symmetry. Do you know how to do this? We got to take these 2 values,
And
add them, and then what? Good. So to find the AOS, axis of symmetry, we add the 2. They usually call them, remember I'd written way up above R and S? That's usually the formula is written. You add R and you add S together and divide by 2. So they say R plus S divided by 2 gives it to you. Well, in this case, R and S are 0 plus negative 2.
Just negative 2.
When I work that all out, do you know what we're going to get? That's right, negative 1, which makes sense. Negative 1 is right in between negative 2 and 0, right? So we know the x value of the vertex is negative 1. We've got to find the y value. In order to do that, we take our x value and we plug it into the original equation. Okay? So this is what I mean by that. Here was our original equation. Okay? And what we're going to do is we're going to take our x value, which is negative 1, and we're going to plug it in for both x values in here. And then we're going to solve for f at x or the y value. That's what it's known as. So let's go plug it into that equation. The equation was, again, f at x is equal to 2x and x minus 2. We discovered that x minus 1 is the vertex, so we plug it in. F at negative 1 is 2 times negative 1, and in brackets, negative 1 minus 2. So we've got to work this out. What's 2 times negative 1?
Negative 2.
Yep. Negative 1 minus 2?
Negative 3.
Yep. Negative 2 times negative 3?
6.
6, that's right. It's positive 6. So I've kind of drawn the parabola wrong because the y value is 6. So really this parabola is above the x-axis, which doesn't make sense. Let's just double check something here. So we've run into an error here because we know this parabola opens upwards and we know we have x-intercepts. Well, in order to have x-intercepts open upwards, the vertex has to be below the x-axis. This one's telling us that the vertex is above the x-axis, which can't be. Because if it opened up and was above the x-axis, we wouldn't have any x-intercepts. So what we're going to do is I'm just going to open up the page a little and quickly take a look. It was 2x and x plus 2, 0 and negative 2. When we plug those in, oh, there it is. I found the mistake. Let's jump back down. So this is good because we were able to find an error and kind of figure it out. If you notice, this says x plus 2. What did I write down here? Yes. So that's definitely an error, which is kind of good because we figured that out. So that's going to change things. What is negative 1 plus 2?
1.
It's 1. What's negative 2 times 1?
Negative 2.
That's right. So the y value is not 6. It's negative 2, which is good. Don't disappear. Okay? And that makes sense because it is below the x-axis. So it's negative 2. Okay? And then we would factor to find the last one kind of like that. So our last one would be our standard form, and we either turn it into vertex form or to factor form and use one of those methods to solve. Okay? And we can talk about how to change that in a different